So for our 10.3 day 2, the notes was just me just going over the entire unit circle, but the homework is really a review of everything you've learned thus far and making all of the connections. So I actually would like to go through and do some of the homework problems with you and get you started so you see what I'm looking for from each of you. The first problems that I'm going to do with you is 5 and 6, which is where we are supposed to list the reference angle for each of the following. I know it doesn't say that you have to draw it, but you would benefit from the practice. So I'm going to have you draw the angles and then identify the reference angles for each of these. For number 5, a 210-degree angle, if I were to draw that, here's 0, here's 90, here's 180, here's 270. Okay, so I'm going to stop there because I know that 210 is between 180 and 270. 210, we want to draw it as close to where it should fall as we can. So I'm starting at my initial side, because it's in standard position. I'm going to rotate in a counterclockwise rotation because this is positive. I'm going to go past 180, but 210 is pretty close to the 180. It's actually just 30 degrees off from 180, which is good information for us to know when we're trying to identify the reference angle. So just as a little reminder, that's my theta. Your reference angle you get by connecting your terminal side to the nearest x-axis. So my nearest x-axis is the negative x-axis. I know I'm saying that a lot. And your reference angle in quadrant 3, this is past 180, okay? So theta is going to be larger than 180. So we're going to do theta minus 180. This is a rule that you learned in an earlier video. So theta prime is 210 minus 180, which is 30 degrees. Or honestly, you could do this in your head. I know that if this is 210 and this is 180, just simple math tells you, hey, look, I went 30 degrees past the 180. That should be my theta prime. So that's the answer that I'm looking for. The next one is, it's a radian, and I showed you a really quick shortcut. Whenever you have a radian, theta prime is just a positive theta, or excuse me, a positive pi over the denominator. So theta prime is pi over 3. But I did say I want you to practice drawing your angles. So I'm going to, if this is 7 pi over 3, I know this is 0. I know this is 3 pi over 3 because that's 1 pi. And this is 6 pi over 3. I already, just by doing this, I can tell where it's going to fall. I see that 7 pi over 3 is bigger than 3 pi over 3, so I know there's at least one full rotation, and it's 1 pi over 3 past this, so it's right here. If you wanted to label the other ones, halfway between 0 and 3 is 1.5, so this is 1.5 pi over 3, and this is 4.5 pi over 3. You could have also converted it to a different denominator. But yeah, so there's a full rotation. Also, you know what that's called? A coterminal angle. This was 7 pi over 3. If I subtract 2 pi, which is 7 pi over 3 minus 6 pi over 3, because, hey, common denominator if you're adding or subtracting, that's pi over 3. So 7 pi over 3 and 1 pi over 3 are coterminal angles. And because of the unit circle, you should know exactly where that is. Make sure it's representative of a 60-degree reference angle. So you can either write pi over 3 or you could write 60 degrees because those two things are equivalent. Now I'm going to do 13 and 14 with you, so one of each where you're asked to rewrite each degree measure into radians or each radian measure into degrees. So if you start off with degrees, you're going to want to multiply by pi radian over 180, because technically this is equivalent to 1. Pi and 180 are the same thing. You'll notice that your degrees cancel out, so we're going to be left with our unit of radians. 135 divided by 180, that does simplify to 3 over 4. So I have 3 pi over 4 radians. Number 14, I didn't write it, but this is already in terms of radians. Maybe by writing that, it'll be easier to see what cancels out. When you are given radians, you multiply by 180 degrees over pi radians. So you see it's just the same values just flipped. It's the reciprocal of what we just used. The radians cancel out, but that's not the only thing. The pi's are gone too. So I'm just left with 180 degrees divided by 4, and 180 divided by 4 does simplify. That would just give me 45 degrees. Now we're going to be evaluating functions without the use of a calculator. You should not be using your calculator at all. So if you have your calculator out, put it away. You don't need it, and you won't be allowed to use it on your test. I don't want you plugging these into your calculator. I don't want any decimals. I want exact answers. So we already went through the steps of this before. Feel free to go back to your 10.3 day 1 video to see how exactly we evaluate it. But the first thing that I should do is sketch a graph of 130 degrees, or excuse me, 135. Okay, so here's 0, here's 90, here's 180. I know that 135 is actually exactly halfway between 90 and 180. So I'm just going to draw this terminal side right here, and here's my initial side. That's my positive theta. Okay. There's a couple ways you could see this. Personally, when I look at this, I say, all right, well, my theta prime needs to connect the terminal side to the nearest x-axis, and the nearest x-axis is the negative x-axis. And I'm just going to see how many degrees away from 180 it is. So it's 45 degrees away from 180, so theta prime is 45. Or you could have the equations memorized. I know in quadrant 2, theta prime is equivalent to 180 minus theta. So that's 180 minus 135, but hey, look at that. That's 45 degrees. Now I'm not done yet. All I found is the reference angle, and that's pretty important because now when I draw my special right triangle, if it's a 45 degree theta prime, I know that the measures are root 2 over 2 for both legs. However, you must keep in mind what the signs are. In quadrant 2, the x value is negative, the y value is positive. Now, it asked for tangent of 135. Remember, tangent is y over x. So tangent is going to be, I'll write it right here. Tangent of 135 is equal to the y value, which is positive root 2 over 2, over the x value, which is a negative root 2 over 2. Anything over itself is just 1, but there's a negative sign, so hey, that's negative 1. All right, now I would like to do number 25 with you. Number 25, once again, let's sketch our angle real quick. Here's a negative 45 degree. I know it looks a little off, but because it's negative, I go in a clockwise rotation. So I started at 0, and here's negative 90. 45 is exactly halfway between. Theta prime is connecting your terminal side to your nearest x-axis. So that right there is my theta prime. And it should be fairly obvious just by looking at it. Hey, theta prime is 45 degrees because that's how many degrees it is away. If you wanted to use the rule, and the rule for quadrant 4 is theta prime equals 360 minus theta, you'd have to make sure you have a angle measure between 0 and 360. So you'd have to find a positive coterminal angle. So negative 45 plus 360, and that gives you 315. So 360 minus 315, hey, look at that, 45 degrees. So that's really up to you. I think it's easier just to look at it, but you go for however you think you want to solve it. Now, because it's 45, I have root 2 over 2, root 2 over 2, but keep in mind the signs. X is positive, Y is negative. Now, I want the cosine of negative 45. So cosine is the x value, meaning that cosine of negative 45 degrees is going to equal a positive root 2 over 2, because that's the x value. You don't have to put the positive sign there. I was just emphasizing it's positive, not the negative, because it's the x value. All right, I'll do another one with you. Why don't we take a look at 37? So 37 is a cosine of 0, okay? Cosine of 0. Well, here's 0 right here, okay? That's 0 or 2 pi, or that's 0 degrees, 360, however you want to think about it. It's right here, okay? I do know that the coordinate is going to be 1, 0. So we already know what the x and y values are since that's a quadrantal angle. And because it's asking for cosine, I know I want the x value. So that's just 1. And that's it. That's all you got to do. Just a couple of reminders. The cosine is the x value, the sine is the y value, tangent is y over x. If you wanted secant, cosecant, cotangent, those are all the reciprocals of sine, cosine, and tangent. I have time to do one more. I'll just do one more with you. How about let's do number 30. So number 30, I have sine of 2 pi over 3. So this is 0, this is 3 pi over 3, this is 6 pi over 3. I know because of my unit circle, 2 pi over 3 is right here. Because here's 1 pi over 3, 2 pi over 3, 3 pi over 3. I also know that the reference angle is just pi over 3, so you could use that to draw it, meaning that there's a 60-degree reference angle. So here's a 60-degree reference angle, meaning that the y-axis is the longest leg, which is root 3 over 2. The x-axis is the shortest leg, so that's 1/2. But it's in quadrant 2, so the x value has to be negative, the y value has to be positive. And I wanted the sine of 2 pi over 3. And sine is the y value, so sine of 2 pi over 3 is a positive root 3 over 2. Again, you don't have to put that positive there. I'm just enunciating. Hey, quadrant 2, that's a positive y value. All right, you should be pretty good to attempt the rest of your homework, and I'll post the key after the deadline. Remember, no calculator, and on this whole page, you need to first draw the picture, identify your theta prime, use your special right triangles to fill in the side lengths, and then you need to evaluate the trig function it is asking for.